Welcome to EDU World Space.
This is chapter 21, problem number 36. We're given this figure that consists of 2-point charges, Q1 and Q2, and P at a point P, X away from Q1. The net electric field due to these two charges are given to us as 0. And we're asked what X is. So at point P, there are two contributions, right? Due to Q1, there is going to be the electric field emanating from Q1 at point P, and then there's going to be the electric field generated by Q2 at point P. So let's look at the direction of these electric fields, and then we can calculate the magnitudes. So since Q1 is a negative charge, the electric field emanating from a negative charge is always radially towards the charge itself. So then if we want to show the direction of E1, the electric field generated due to Q1, then it's going to be towards Q1. So using the same logic, if we have a positive charge, the electric field at an arbitrary point away from this charge is going to be radially away from this charge. So here goes our E2. Then, as you can see, E1 is along positive x direction and E2 is along negative x direction. And the magnitudes, let's see, the magnitude of E1 is going to be equal to K times the magnitude of the charge divided by the distance between the charge and the point of interest. In this case, it's going to be x squared. And then let's write it vectorally. Then we're going to only put I hat there because E1 is in the positive x direction. If we write the vector form of E2, again, first let's write the magnitude K Q2, the absolute value of Q2, divided by the distance between the charge and the point that we're interested in. So it's going to be x plus 0.12, I converted it to meters from centimeters squared, right? Now, since we're writing it in the vector form, we're going to put negative I hat there because the electric field E2 is in the negative x direction. Now, when we add these two vectors to each other, as it's given to us in the problem, the net field at point P gives us 0. Then let's write what E1 is. K Q1 over x squared I hat plus K Q2 over x plus 0.12 squared negative I hat. From here, since this equals to 0, then K Q1 over x squared I hat equals K, absolute value of Q2, x plus 0.12 squared I hat, right? Since we took it to the other side. So I hats are going to cancel out, k's are going to cancel out, so we're left with magnitude of Q1 over x squared equals to the magnitude of Q2 over x plus 0.12 squared. Okay, so this is an important equation. Now, what we're going to do, then, let's do it on the next page. All I'm going to do is I'm going to divide the left-hand side by Q2 and multiply it by x squared on the second page. Then what I'm going to have is Q1 over Q2 then equals x squared over x plus 0.112 squared, right? So we can just start calculating things a little. So magnitude of Q1 is 25 times 10 to the power of negative 6 coulombs, right? Divided by Q2 is given to us as 45 microcoulombs. So it's this. So when we take the ratio, it's gonna look something like 0.555. It goes on forever, so I'm gonna put this. Now let's look at here. If we take the square root here, and obviously the square root of the right-hand side, this gives us x over x plus 0.12 equals to the square root of 0.556, which is 0.745. So then from here, x is going to be equal to 0.745 times x plus 1.12. So then if we redistribute this, what we have is 0.745x plus 0.09. So if we subtract the 0.745 from each side, then we have x minus 0.745x equals 0.09, right? So here 1 minus 0.745 times x equals 0.09. From here, we're gonna get 0.255 x equals 0.09. If you divide both sides by 0.255, then we get 0.353 meters. This is the distance from Q1 to the point P.